We are told that this function has a local maximum and a local minimum, and we need to find the coordinates of the points where the local maximum is and where the local minimum is. And the way we're going to do this is we are going to simply take the derivative of y, and then we're going to set it equal to 0. Let's imagine, I don't know what this function looks like, but let's imagine that, I don't know, it comes from here. So it has a local maximum here, and then a local minimum here. It should look something like this. Although I do suppose it would touch the x-axis. We're going to find out soon. And we need to find this local maximum and this local minimum. Now, we're going to do this, as I said, by taking the derivative. So let's go ahead. We're using chain rule here. So first times derivative of the second, and derivative of the second is going to be, we swing down the 2 ln x, and then the derivative of the piece inside, plus second times derivative of the first. Derivative of the first we don't care about. The x's cancel, and we are left with 2 ln x plus ln x ln x. Right? You can factor ln x from this, but it really isn't necessary. Next thing that we do is we set this equal to 0. Because where the first derivative is equal to 0, there is a maximum or a minimum, because the function at that point changes, or not necessarily, but most of the time changes from changes slope from positive to negative. And from this it follows that I suppose we do. It's easier if we do factor ln x after all. Ln x, 2 plus ln x. And now the first part tells us that ln x is equal to 0. The second part tells us that ln x is equal to minus 2. From this we get that e to the 0, of course, is 1. And so our first x is 1, and our second x is e to the minus 2. Yeah? Now we don't know which one of these is a local maximum and which one is a local minimum. From what I have here, I assume that that this one is, but without a calculator I don't suppose you would know actually what 1 over e squared is. So let's just go on. We need to find out which one is the maximum, which one is the minimum, and that we're going to do by taking the second derivative. And the second derivative, let me just push this up a little bit, because I can't write in this thing. The second derivative is going to be 2 ln x, 2 times 1 over x, plus, and now we have ln x squared again, 2 ln x times 1 over x. Now when we set the second derivative, we don't have to set this equal to 0, but what we do now, we know that this is f derivative of x. When we plug in 1 inside for x, so the function of the second derivative when x is 1, this will tell us something about the point 1. It will tell us whether it is a maximum or a minimum. It is a maximum if the value is negative, and it is a minimum if the value is positive. This is because it tells us what the change of the rate of change is, right? So what the change of the derivative is. If it changes into a negative, from a positive derivative into a negative derivative, that tells us it is a maximum. If it changes from a negative derivative into a positive derivative, that tells us it is a minimum point. And from this it follows that we get 2 plus 2 0. This is 0, so it's just 2, right? 2 plus 0 I should write, because ln of 1 is 0. So it's just 2. That means that this point here is our minimum. And because we need to find the coordinate, we're not actually done. And I'll do this, well, let's just do it now. Y is equal to 1 ln 1 squared. Again, this is 0. And so 1, 0. For our second point, e to the minus 2, we plug that in, and this is now about to get a little bit trickier. 2 times 1 over e to the minus 2, let me just separate this, plus, I'll write this downstairs here, let me just write this again, 2e squared plus 2e squared, and then ln of e to minus 2 is going to be minus 2, which gives 2e squared minus 4e squared, which gives minus 2e squared. And considering that this value is a negative, this tells us that we're dealing with a maximum. Therefore, we take e to the minus 2 and we plug it into the equation to find, oh my goodness, I hope you were able to see this. Our equation up here was y is equal to x times ln x squared, and then we're going to plug into that our second x value, ln e to the minus 2 squared. This gives e to the minus 2 times, again, e to which power is e to minus 2? Obviously it's minus 2. And then when we squared that, we get 4. So 4e to minus 2. And that gives our second, where can I squeeze this? Our second coordinate to be 4e to the minus 2. I'll just put it down here. 4e to the minus 2. And the y value is, this is the y value. See, I'm trying to pay attention to what the camera is showing and what I'm doing at the same time. It's not working. E to the minus 2, obviously, and 4e to the minus 2. That is our second point. That is the maximum, and again, this is not working. That is the maximum. I'm going to have to find a different system. That is the maximum, and this here is the minimum. So it turns out that my function drawing, or rather guessing, was right. And again, to recap with the theory, when you find the first derivative and set it equal to 0, you get the x values where the function, where the derivative is, where the derivative is 0. However, you don't know if it's a maximum or a minimum until you find the second derivative and plug that x value into the second derivative. Then the second derivative tells you whether the change of the derivative is from negative to positive or from positive to negative. Think of it as the opposites. If the value that you get from your second derivative is positive, then the x value is at a local minimum, and if the second derivative gives you a negative, then it is the maximum. So positive minimum, negative maximum. It's the way I remembered it. And once again, for a recap, these two are our solutions.